It's Damon from NZ Builders, and just want to talk to you about the thermomass system that we're doing on this project. This job site was very challenging. It's basically 3 stories deep, and we didn't have crane access where we would typically use our tilt-up or precast concrete insulated panel system. We opted to use Alumiform for our forming system, and what we have created is basically a sandwiched wall system. So this is what we've created, but instead of pouring it flat like we do with the tilt-up and our casting tables, we're pouring it vertically. And the difference is there's the pressure that is put on the form systems when you pour concrete on a vertical position up to, we're doing 14 feet pour lifts, there's a lot of pressure on coming out in every direction. So you've got to have a super robust form system, which is why we chose Alumiform. It's all engineered. The good thing about this product is your tie holes are very spread apart, not like a quick strip or a snap tie system where it's every 16 inches. So the makeup of this wall is 20 inches. We've got 4 inches of exterior veneer layer. That is typically 2 to 2.5 when we do the tilt-up system. It's structural. We can actually bolt things to the side of this for structural connections. We've got awnings and things, which is kind of nice. The insulation is 6 inches typically in the tilt-up. We do in the panelized concrete sandwich panel system, we do 8 inches because the cost from 6 to 8 is minimal. And then we usually do 6. This is actually 10 inches of concrete here. There's a lot of structural rebar in this home. When you're doing the concrete tilt-up panels, you're relying on a lot of connections between the panels, welded connections and bolted connections and floor diaphragms. So this was going to be a very, very robust home. So the thermomass system, how that works, it's made by Damon, and it is made with these pins hold the insulation in the middle of the form. So what you do is you drill the hole through the insulation. You've got these washers you click on and you can adjust them, and then this other washer comes on and you sandwich that up against the insulation so they're in there nice and tight. Now this pin goes up against the surface of the plywood and it holds this in place while you're pouring vertically. We ran these every 12 inch on centre in this project, and we also used a 200 kPa EPS insulation. The reason for the 200 kPa, it's a geofoam, it's structural foam, is because when we were pouring this we were hoping for more this to be rigid and we can get higher lifts out of the pour. So we were able, the nice thing about the Aluma system is we could do a full lift on the one side before we poured this side, and what that gets rid of is our cold joints as we go around the house. Another thing to note is we used HAO plywood. It has a very smooth finish to it, almost like a formica, and when you're using the right release agents, we use the release agents from Knoxcrete, and when it's compatible with that plywood, you reduce the bug holes and the air bubbles. One thing I want to point out is when let's say you seismically calculate your house, to go to a class F, which would be a fire hall, the cost isn't that much difference. So always advocate for clients to do the upgrade. For one example, it was $2,500 for one house that we were doing. And for the money, I feel that is important. You can be the fire hall, bringing in all your friends and in an event that they unfortunately might not have their home left in.